Today I'm talking about options. In the first 2 weeks, we've dealt with financial situations where we know what's going to happen. Today, we're going to deal with financial situations when we don't know what's going to happen. And that's going to be the beginning of a wonderful journey, because a lot of what's left in this course is going to be concerned mostly with that, dealing with situations where we don't know what's going to happen. And for that, I'm going to play 2 games. And I would like to have someone who's willing to play with me. I need 2 people to play a game with me. Oh, wow, that's great, fantastic. So I'm going to get the people closer to me so I can interact with them. Okay. I know that people like to sit in the back. Some people like to sit in the front. That's your choice. When it comes to playing, so you and you. All right, very good. Okay, and you can watch. Okay, thanks. All right. So, and I'm going to be telling you about options in episodes every time. Maybe 5-10 minute episodes, maybe half an hour. We're going to be climbing a hill. I like to use that analogy when you're struggling to understand something. So we're going to, each episode is a little hill we're going to climb. We have to climb it together. And I hope by the time I'm finished, we're all at the peak together, so we can climb the next hill. There's going to be 6 or 7 or 8 episodes we'll do today. I don't know how many. We will see. Okay, we're going to start with the simplest one. All right? Now, episode 1 is pricing. I'm going to start with a very simple game. I'll play with you. Your name? Rahul. Okay. Rahul. Yeah, good. Okay, so I'm going to play with Rahul. And this is the game we're going to play. Remember, for about a month, we all work for free. We're not aiming to make money. We're not aiming to lose money. It may sound like either absurd or naive. No. The reason is, once we understand the world without profits and without costs and without benefits, then we can have the right modification for that. So we're going to all work for free. Okay? If someone makes money for free, we're going to be very, very concerned. We have to remove that somehow. It's not a political statement. We'll change that in about a month. Okay, so this is the game we're going to play, you and I. I'm going to take a coin and I'm going to flip it. If heads shows, I give you $1. If tails show, I give you nothing. The question is, how much are you willing to pay to play that game?
49 cents.
49 cents. I would object because, remember, we're trying to not make money.
50 cents.
50 cents. Thank you for that. Okay, so 50 cents will be the price at which we make. I make no money, you make no money, right? But that's not exactly right, because sometimes I'll make money, sometimes you make money. And we think that over time, that is going to clear up, right? Okay, so that's the game you and I were going to play. And yes, the answer is 50 cents. You know that. Now, let's reflect on that. We have no certainty. We're going to flip a coin. Maybe you win, maybe you lose. For sure, every time we flip, someone wins, someone loses. We don't know who that's going to be. And the more times we play, the more fair the game becomes, because the law of large numbers and all of that says that over time, we're going to be more or less even relative to how much money is at stake, right? Of course, we could have tremendous deviations, and then you end up making, if we play 1 billion times, you can make $1 million from me, right? But of course, $1 million relative to $1 billion at stake, that goes to zero. That's what the law of large numbers says. We know that. This is a probabilistic model, and it's the model where most games are based on. You go to a casino, that's the model that works there. Okay? Good. Now we're going to play a slightly different game, and that's going to be with you. Your name? Harsh. That's right. Harsh. Yes, in fact, I knew that, and I forgot. Your fault that I forgot. Okay? Remember, it's your responsibility that I learn your name by the end of the course. And you get a Mark, if I remember your name. Harsh. Your game is going to be it's going to look the same. There's going to be a certain asset, it's worth $1, and then with a 50% probability, someone flips a coin, the asset is going to go to $2. And if tails show, the asset value is going to go to 50 cents. All right? So I'm going beyond Rahul's game by saying the coin flip is actually going to trigger a price change of a certain asset. The asset could be your house, the asset could be Bitcoin, the asset could be a stock, don't care. An asset. And if the asset goes up in price, I give you $1. That's what comes next. If the asset value goes down, I give you nothing. In fact, to make the situation a bit more extreme, I would say that someone could be flipping a coin there. One of you, like you, you could flip you could be the coin flipper, and then I trigger the payment to you, and then I trigger the payment to you from the same coin flip. Could be, right? But these are two different games. And now the question to you, Harsh, is how much do you pay to play this game?
It would at least be 50 cents, but then you also have to consider the value of my asset going up and down.
Okay, so for the sake of playing this game, sorry, not for the sake of playing, for the sake of explaining what I'm going to explain, you would pay 50 cents, right? Okay, so let's say, thank you for that, okay? Some of you already know that the price is not 50 cents, but right now I prefer to deal with an ignorant player. And the reason is there's something to learn if I deal with an ignorant player, okay? If you're an experienced option trader, I'll have a problem. I don't want to play with you because we'll do the price is not 50 cents, as you can imagine. Otherwise, why am I playing this game? But I want you to understand why. Why? Okay, so this is the situation. 50 cents is the wrong price. Imagine this. Imagine you pay 50 cents to me. I want to show you the journey of your 50 cents, because that's what I would do. As a finance professional, I would do this. I will collect your 50 cents. You see that? Thank you, 50 cents. And I collect that before they flip the coin, before I know where the asset goes. Imagine that I collect the money today and then the asset would go up or down in price tomorrow. Okay? And then, so I collect the money from you today. Then what I want to do is, without waiting till tomorrow, I want to borrow 20 cents from my bank. 20 cents. Could be a different number, but 20 works. And then with my 70 cents, I buy 70% of the stock. I'm buying 70% of the stock? How is that possible? We're still in this make-believe world where no one makes money, everybody works for free, we can buy negative amounts of things, fractional amounts of things, right? We're mathematicians, this is important. So I buy 70% of the stock. And then I go home, I have my dinner, go to bed, and I wake up the next morning. Then one of two things have happened. The stock went up in price. That's possibility number one. If the stock went up in price, I have to give you $1. Yeah, I'll give you $1. Give me a second. This is what I would do before I give you $1. I sell my stock. I bought 70% of the stock, so that's $1.40. Right? Then I give you your $1. Then I return my loan of 20 cents, and I'm left with a profit of 20 cents. Everybody sees the profit? Oh. Well, you may be thinking, what happens if the stock goes down? If the stock goes down, my 70% of the stock is worth 35 cents. I don't have to give you anything. I return my loan of 20 cents, and I make a profit of 15 cents. Oh. What happened here?
Arbitrage.
Arbitrage. So there's several consequences from this example. By the way, there's no trickery here. It's all, you see the numbers, they're correct. I did not make a mistake. Yes? So, arbitrage. This is very quickly declared to be illegal. This contradicts my assumption that no one makes money for free. By the way, you say, well, let's play 1 billion times. Sure, let's play 1 billion times. At that point, I don't care about no one makes money. I make money, and I make a lot of money, right? I make a lot of money. You, I'm not sure. Maybe you make money too. Now that's economics, it's not finance, right? I don't know why you did this deal. I don't know. But I know that I am the bank, I'm the dealer, so I'll make money every time we trade. Yes, sir?
So when you buy 70% of X, that's like 70 cents. How do you take, where do you take that into account in your profits?
We're taking into account that I bought 70% of the stock?
Yeah, because 70 cents, right?
Well, he paid 50. I borrowed 20, 70 cents. I buy 70% of the stock. Right? If I had borrowed 25, it will work with any number, by the way. Okay? If I borrowed 25, I would buy 75% of the stock. The numbers will be different, but I'll make money too. In fact, I'll make money under every scenario, no matter how much I borrow, how much I buy. I will always make money. Okay, this is our first hill we just climbed. Not very steep, but something fundamental has come up. Which is options. This type of finance requires a type of thinking which is new. It is not the thinking that you learned when you studied probability and statistics. It is not. It has to be something different. And that's what I'm going to show you today. So, in this case, one side always wins, guaranteed. That's me. Again, I'm not talking about you. I don't know why you did this, okay? And it's not clear that you make or lose. But I always win. So that breaks our assumption that, options for arbitrage. And the more we play, the more I make. So this is not very different from our game, right? There's no law of large numbers here. It's something different. And as you said, 50 cents leads to arbitrage, making money for free. Therefore, it's the wrong price. That's the only possibility. And what has radically changed is that this is no longer a probability game. This is a financial game. And very quickly, we will see that it's actually not a game, something else. It looks like a game, but it's not a game. So the price is 1/3. The reason is this. We go back to our game, and now you're going to pay me, say, 1/3, 33.33 cents. Yes? So what I do with your third of a dollar is I borrow 1/3 of a dollar, I buy 2/3 of the stock, go home, have my dinner, go to sleep, wake up, and then if the stock goes up, I have 4/3. I give you $1, I return the loan, I make nothing. If the stock went down, my 4/3 become 1/3. I have to give you nothing. I return my loan and I make nothing. The price, therefore, is 1/3. Okay? Yes. I have a lot of comments now. We're going to talk about this because let me start with your questions. Rahul.
How are you choosing how much to take a loan for?
Okay. That's because I'm very smart and I've seen this before. But by the end of today, you will know too. Just stay put, okay? Stay put. Math will tell you how. Don't worry. Stay there. Keep watching.
I was going to ask, when do we have to use a loan?
Why we have to use a loan?
Yeah, no, do we have to use a loan or can we price it?
No, you have to use a loan. And that will become clear also today. All of these things will become clear today. Yes?
Doesn't this mean that I would make more money on average then?
No, you will not. and that will come up also today. There's a lot of things that will that we will learn from this little game. By the way, this little game is going to be with us for a month. We're going to play this game in different forms for a month. I'm going to refer to you over and over and over to the 33-cent game. It's going to come up in everything we do for about a month. Okay? This is not to be forgotten. This is so important that I want to tell you a little bit of history that will resonate with you. And I'm going to tell you the history with this game as the allegory. You know what an allegory is? Okay, brush up on your poetry. Okay. All right. So this is what happened. I'm exaggerating a little bit. Okay. Someone may be watching this on YouTube and say, "What is he talking about?" What I'm saying is true, but it's actually just a slightly bit exaggerated. I did my PhD at Princeton in 1989, from 1985 to 1989. And at that point, the fancy thing to study was physics, solid state physics. Everybody wanted to do that. And there were so many students with a PhD in solid state physics that it was really wonderful. That's when physics started to grow so fast that very quickly they ran out of experiments to be able to somehow prove all the wonderful theories that were being developed by all those numbers of students. And because of that, it was very difficult for all of those graduate students to get jobs in physics. Physics could not employ so many PhDs in that. So many of them went to Wall Street and they worked in the banks, doing something that it seemed was going to be something different. The banks just hired smart people and didn't care if they were experts in string theory or quarks or what, didn't matter. They just hired them. Then they were there, and for reasons that will become clear maybe in a month or so, they started, and this is my allegory, they started to see that these types of options, people were paying 50 cents for them. But then they quickly realized what I'm about to show you today, which is that the price is actually 33 cents. What do? You go to work. Again, my allegory, you go to work, you've learned this, and people are willing to pay 50 cents for this option. When you're working, we no longer have this rule that no one makes money, okay? For free or not for free. You're there to make money, right? So what do you do if people are offering 50 cents for this option? What do you do? So,
you just sell it.
Yeah, well,
You funnel clients from your bank, like on the side, and just sell the option for 40 cents or something.
that's what you would do? That's what I would do. By the way, I would not teach them anything. I would sell it to them for 50, maybe 49, whatever price I can get them to pay, right? That's what I would do. You don't go and to say, "Oh, excuse me, the price is 33, look," right? You don't do that. They said, "Oh, you're going, they sell it, you're going to buy it from them for 50, buy it from me for 49. How's that?" I said, "Oh, that's great. Yes. Can I buy more?" I said, "As many as you want." Right? Yes? Now, there's one thing missing in this argument, but that's why I want you to understand the situation, which is, you may say, wait, I think I'm taking a lot of risk here because I'm selling this option at 49 many times. How do I know? Well, I know because I can go and trade this, right? You see, the fact that I can borrow money, who asked you about borrowing money? The fact that I can borrow money and I can trade this, well, then the only thing I need to do is I need to secure a line of credit because the stocks are there to be bought. If I'm at a bank, I said, "Can I borrow $1 million from the bank?" I said, "Yes, you can borrow." They will charge you for that, okay? So here we're not paying for that. Quickly, all these things will become clear and will become, everything will remain perfect once we make it more realistic. But again, continuing with my allegory, if you can borrow $1 million from the bank, you can play this game how many times? 3 million times. right? That's a lot of money you're going to make. And you're going to make for free and for sure, right? And then people at the bank will say, what are these guys doing? They didn't understand. So this had a name. It was not mathematical finance, it was practical economics. Because all those people doing this came mostly from practical physics in the universities in the West Coast. You understand? Fantastic. Fantastic. Now, many things happened after that, and when we talk about risk management in about a month or so, I'll continue with the story, and I'll tell you what happened in 1987, October 19, 1987, when all of this blew up in a certain way. Okay? That's a different episode. Stay tuned. Okay? In a month. But coming back to this, I think we understand what's happening here. It's clear. You've gone through the calculations and you see that there's no mistake. It's all correct, right? And the price is 33 cents. And now we see that we're playing a financial game, and earlier we were playing a probabilistic game, no relationship. And the biggest impact of this is that in the game I'm playing with Harsh, there's no risk. I know that at least I am not going to lose money. And because of that, this price is called arbitrage free. Okay? Great. Now, some facts. We're about to climb the next hill, and for that reason, I need to settle some facts. The price of the option is independent of the probability of stock movements. You can go back and say, well, what about if I change the probability from 50 to 75%? I don't care. The only reason I gave you the 50% chance of the stock going up or down is to confuse you. Right? We never used it. We don't need it. The price of this option is only a function of the value today and the possible values tomorrow, not the probability of the values tomorrow. So to think that this is a probabilistic game is not true, with one small comment, which is those probabilities cannot be zero. It will come up later, right? About an hour or so, you will see why these probabilities cannot be zero. If they are zero, something else will have to happen. We came up with the concept of the replicating portfolio, which, by the way, is exactly the same replicating portfolio as the one we built last week. Either to value the stock forward, remember, or the bond forward. It's exactly the same process. It's just that this one may seem more sophisticated. The bond forward was very easy. I borrow and I buy the stock and I wait. In the bond, I had to buy 2 bonds and then wait. Here, I have to charge you, take a loan, buy the stock, and wait. But it's always the same. The idea is that with my replicating portfolio, what looks like a random outcome is actually not random. That's what's called replicating portfolio. And the replicating portfolio, how do I find it? Someone say, how did I know I had to borrow some money? Well, that comes from a system of equations that what I'm about to show you. Very simple system of equations. Okay? So my episode 2 is I'm going to tell you about replicating portfolios because they are the ones who hold the key to understanding what's going on. You're with me? Did I leave anybody behind? Everybody's with me? Yes? Are you struggling in this first peak we're climbing together? Anybody? I really need to make sure you're all... This is not hard. By the way, nothing we will do today is hard. Not today. Tomorrow? Next week? Maybe. Not today. You're all together? Yes? I'm not missing anybody? If I'm missing anybody, raise your hand immediately, okay? It's very easy to catch up. Very easy. Going once, going twice, solved. Okay, great. So then let me tell you about replicating portfolios. We're in this situation. We have a certain stock with a certain price, and some future possible prices. Yes? And we're going to play the game, and we're not thinking about the game price anymore. We don't think that way. We think of the replicating portfolio. I'm thinking, what can I do to remove all the uncertainty from all of this? That's how you think about replicating portfolios. In a couple of weeks, or maybe next week, at some point, I'm going to ask you a question in the quiz. It may look like I'm asking you to price something that might happen. No, think. Your objective with replicating portfolios is to figure out what you can do so that whatever happens, your replicating portfolio gives you that. Okay? All right. So, what would happen? Very simple generalization. If now I have to pay for my loan, it's not for free anymore. What would happen? If interest rates are non-zero, then if I have to pay for the cost of borrowing, then I will have to adjust the replicating portfolio. This goes back to the other example I told you earlier, that if I can borrow money from my bank to do many of these, the bank is not going to lend the money for free. The bank will charge me, let me tell you, two things. They will charge me the ongoing rates, which you calculated in your assignment number 1. How much will they charge me? What's the rate? Assignment number 1, what's the rate?
3%.
3%, right? This is a 1-day loan, right? So what's the 1-day rate? 3%, right? They charge me 3% plus banks like to make money. They will probably charge me 5% on top of that. Yeah, 5%. That's the return banks are looking for on their own money. 5%. So they charge me 8%. Okay? You may be thinking, hey, wait, but I work for the bank. And then I will tell you, so what? You work for the bank means they have to make money from you, right? When you go and work in a bank, don't forget they will be making money from you, and your objective is to make money from them too. That's the employment contract, right? I'll tell you how to negotiate that the last day of this course. That's a different topic. All right. So let's figure out how we can find the replicating portfolio in this particular case. If I had told you this at the beginning, you would say, oh yeah, of course, a system of equations, big deal. No, but then you would have missed the magic and the mystery of what we're doing. So I like to start that way. So if I'm dealing with this situation, and if I'm searching for the replicating portfolio, this is how we think. I'm going to construct a portfolio of stocks and bonds. Before you ask me, how did I know it was 20 cents I had to borrow? It didn't matter. And now you may be asking, how do I know I have to trade stocks and bonds and not something else like futures? Don't worry, that's coming too. Okay, we're going step by step. So here I'm facilitating to you the fact that with stocks and bonds, I can replicate this portfolio. In the future, I will need other things, but all of that will become clear very likely today. By the end of today, all of that I think should be clear. So if I'm going to have a portfolio of A, stocks, and B, bonds, a bond is my loan, right? Then this is the equations they should satisfy. If I buy A stocks, A is $1, but that's not the issue. The issue is that tomorrow, if I buy A stocks, the value of my portfolio will be 2A. And if I buy B bonds, the bond will be worth $1 always. So that'll be B. So 2A plus B has to be equal to 1. If the stock goes up. If the stock goes down, the value of my portfolio will be A over 2, 1/2 times A, plus B. B is a bond. It's worth $1 tomorrow. How much it's worth today depends on the interest rates. But tomorrow is $1. Yes? Everybody understand that system of equations? By the way, everybody can solve the system of equations, right? That's how I got the 1/3, 1/3, 2/3, all of that. I didn't invent it. It comes from there. And you get to that system of equations by just thinking about it. Just set up the conditions that your replicating portfolio must satisfy. Clear? It couldn't be easier. It really cannot be easier. This is the easiest example you can have. Oh, yes? My solution is 2/3 for the stock, negative 1/3 for the bond. If I buy negative 1/3 of the bond, that means I'm borrowing 33 cents. If interest rates are zero, if interest rates are not zero, well, whatever the bond is worth today, I don't care. Bonds will be cheaper if rates are higher than zero. I borrow less. Okay? Clear. And by the way, that gives me the price of the option, because the price of the option should be the same as the price of the replicating portfolio. We went through that last week. We went through that 2 weeks ago, and that's coming up again today. If two things give you the same cash flows, they have to be the same today. Otherwise, there's arbitrage. You see, arbitrage is very useful to find prices. And once you find prices, then you know how to take advantage of the competition. But we have to start understanding prices. So if I'm pricing with interest rates, my replicating portfolio is what it is, okay? And I know the bond and stock prices today, stock because it's in the market, and bonds because interest rates tell me. And then I can calculate if interest rates are zero, the value is 1/3. We went through that. But if rates are different, then I just multiply by the value of the bond today. So if the bond today is, say, 90 cents, roughly you have a 10% interest rate or 11% interest rate, then the value of the option will be more expensive, $36 cents. Right? Once you have the system of equations, then that works too. Good? All ready to go to episode 3? Again, I don't want to lose anybody, okay? This is very easy. But it's very easy also to be confused. So what was that? We're good? All right, so the next topic now, and this is going to become, well, it's still very easy the way I'm explaining it to you, but this is an area you can actually do a PhD on if you desire, okay? Not, for us it's going to be 10 minutes, okay? This is the 10 minutes PhD. Risk neutral measures, where are they? So let me tell you this. Imagine I had started class today in a different way. The game I play with Rahul is going to be, no, we don't have a coin flip. There's going to be some sort of other experiment, okay, where the probability that heads show is 1/3, and the probability that tails show is 2/3. How much do you pay? 33 cents, right? Then I would have gone to Harsh and he would have said, oh, sure, 33 cents, and then class is over. We would have missed all the magic, right? That's why it was important that I chose the wrong probability. Because if you had chosen the right probability, you would have led to believe, yeah, sure, I can calculate. No, you got it wrong. Understand? But now that you know that there's a wrong and a right probability, let's go back and be nice to ourselves and say, hey, wait a minute. What did I have to trick you into using the wrong probability? What if now that you know this, what if I tell you, let's work with a probability that gets me the right price doing the wrong solution. Understand? Say, well, that probability should be very special, no? If it gives me the right answer with the wrong process, maybe there's something interesting there. And there is something very interesting. So that's what I'm going to do. So if I go to the stock, imagine I tell you that the value of the stock is $1, and the stock can go to $2 or 50 cents with probability not 50-50 now, with probability 1/3, 2/3. So several things to say to this. First, you say, wait a minute. I told you earlier that the probabilities didn't matter. It's true. I'm not saying suddenly the probabilities matter. But what I'm saying is that probabilities are very useful for other things in life. So why not choose the probability that works? Why not? Knowing that probabilities don't matter. Don't forget that. In fact, let me ask you one question. With a 50% probability, with a wrong probability, look at the stock. It's worth $1 today, $2 tomorrow, or 50 cents tomorrow. What's the expected value of the stock? With 50-50.
125.
125. So this stock is too cheap, right? It's what the price is. If you think it's too cheap, and fine, right? But if you look at the stock and say, well, by analyzing the stock price and the stock future values, it is not too far-fetched to think that 50-50, before we start playing the game, gets me very nervous, right? Because it misprices the stock. If it misprices the stock, sure, it could misprice everything else. You understand what I'm saying now? So this measure we're going to define, this risk neutral measure, is something that we do not just for the sake of pricing the option. It's something that we do because it will have a tremendous relevance for many things that we will do. And when we talk about credit risk later on, in about a month and a half, very, very important. Okay, so it's going to become, the risk neutral measure is going to become a financial construct, just like the yield. So that we can price options or stocks the wrong way, getting the right answer. That's why they are so easy to misunderstand, right? They will help me get the right answer with the wrong method. It's like when you do an exam. Has it happened to you? Go to the exam and then you do something wrong, but you get the right answer, right? And then they give you part marks. Hey, why did I get part marks? Or maybe no marks. Then you go and say, no, you complain. You got the right answer, right? She's laughing, right? You got the right answer, so you should deserve full marks, right? Okay, so I don't care about marks. That's not what I'm talking about here. So, if you got the right answer with the wrong method, let me look at the method. Maybe there's something interesting there. That's all I'm saying. You understand? I'm not giving validity to calculating prices with probabilities. We know that's the wrong way now. We know that. The game we played here shows us it's the wrong way. But if there is a measure that allows us that, at the very least, it could be computationally very efficient. At the very least, because it's a lot easier to calculate probabilities than replicating portfolios, right? I don't have to solve system of equations. It's only one multiplication, right? You all with me? Good. So, in this case, it's not about the price. It's about having the wrong process to get me the right price. So, okay, so 1/3 is the right price with the wrong probability. But now if it's the right price also with the wrong process and the right probability, then it should be important. So the same argument that we had earlier works, because it's independent of the probability, but now the price coincides with the expected discounted payoff, which is something very, very important that we're going to do. The prices that will be priced taking expectations with this wrong measure will still be arbitrage free, okay? And for that, we know the probability has to be 1/3, 2/3. And it seems to be a coincidence that the same probability prices the option correctly and the stock correctly. There will be a theorem that I'll probably prove next week, maybe. It said this is no coincidence. If it prices one, it has to price the other two. It's a theorem. It's called the fundamental theorem of asset pricing, and it's valid for everything, not just stocks and options and this and that. Okay, so once we climb all these mountains and we get to the peak, say, what a wonderful landscape, look at that, all the things that we can do. At that point, we'll do a theorem. A theorem that says that this works, and a theorem that, by the way, says that your yield curve exists and is unique. Okay? This is the same. This is how finance is built. And that's what we're doing. And this is the definition of the risk-neutral measure. It's the one that will give us the value of the option to be the expected discounted payoff. It's very important that we have the discounting in there because, for example, the bond, we know what's the expectation of the bond. It always gives 1, right? If the expectation of the bond is 1, well, today is maybe not 1, it's 90 cents. That's because of the discounting. So that's why we'll always say expected discounted payoff. It's expected because that's what the measure will do, but discounted because the measure can never price the bonds right if we only take expectations. Only when interest rates are 0. Okay? All right, so I think I've told you all of this. And this will be risk neutral pricing. You will see that sometimes it's going to be faster for us to do risk neutral pricing. At that point, it's a matter of speed, not correctness. Okay? All right. Are we ready for the next? Are you all together? Everybody? Yes, yes, yes. I haven't missed anybody? Okay, now I want to talk about incomplete markets, which is, we seem to be getting very good at this. We understand everything. So let me throw a new question. This is a new game. I'm not going to ask for a volunteer to play this game because this is not a game we can play, as you will see. Imagine I have a stock that can do 3 things tomorrow. It's $1 today, and tomorrow can go to $2, $1, or 50 cents. And I do the same thing. This is the stock values, but then I say this stock can lead to a new game, similar to what I played with Harsh, which is I give you $1 if it goes up, and I give you nothing in all other cases. How much do you pay for this game? You've learned enough not to take probabilities now, right? In fact, I didn't give you the probabilities. I mean, you would not fall for that anymore. Will you? Will you fall for that? If I give you probabilities, maybe I should have done it. Maybe you see who falls for that. Right now, after 1 hour of this, you should have learned that probabilities you don't use. For next year, I may change this slide. I may put some probability there, see if someone still falls for that. You understand what I'm saying? Yes? Okay. What do we do? Some of you is probably very good at solving equations mentally, is trying to look for what's the combination of stocks and bonds and this and that. There isn't one. There isn't one. We cannot find the price. So what do we do? What's the situation here? The situation here is what's going on. Let's reflect on what's going on so we can find the solution. In this case, the problem is that we have more future scenarios than securities. So not always we'll be able to find a replicating portfolio. These are things that should start to look like linear algebra, right? When you have systems of equations, if you have more equations than unknowns or more unknowns than equations, remember that? Do you really remember that? Because that's going to become very important. Now, in fact, that's going to hold the key to understanding the relationship between things that might happen and how many securities I have, right? By the way, very similar to your struggles with how many bonds I have and how many yield rates I need, right? It's the same. That's why it should not be surprising that the same theorem addresses all of that. But this is not about theorem. This is about the situation that we're dealing with here. So in these situations, not always we will have a price, unique or even not unique. In the next episode, which I will tell you, we will find there's 2 ways to resolve this. In fact, there will be 2 episodes that will give rise to ways to resolve this. But now what I want to do is I want to reflect on what's happening and the concept of an incomplete market. Okay. And incomplete markets are situations where you have not enough securities, which are traded and whose prices you know, to understand a new security that comes into the market. So the analog in your assignment number one would be like you have these bonds, and then suddenly a new bond comes in, or someone wants to sell a new bond that happens to have maturity that does not agree with the maturities that you've calculated the yield curve for. How did we resolve it there? Well, by linear interpolating. That's how you did it. So you can think of linear interpolation as a way to resolve an incomplete market situation, using the language I'm developing here now. That's a very clumsy way of doing that, but we had no better way. It's like using duct tape, right? So we're going to see today better ways of doing that in the case of options. But at least I want you to understand that what I allowed you to do linear interpolation, is a way to address an incomplete market situation, where the instruments that you have with known prices and with known yields is not enough to understand a new situation where a new financial instrument comes into the market, whether it's the option that we're trying to play here or a bond that happens to mature at a time for which you don't have an exact yield. Understand what I'm saying? Okay. All right, so let me then talk about complete markets, which will tell us in particular how markets can be completed. So let me go back to the example of the incomplete market. I have my stock that can have three possible outcomes from today. I'm giving you probabilities now. And by the way, I have the bond too. The bond will always give me one. It's a bond. It's not a function of the stock. And I'm saying my bond is worth today $1, reflecting the fact that interest rates are zero, or perhaps simply so I can have an example I can walk with you, which is very simple to get me numbers. You know by now that if instead of 1 I write 0.9 or 0.95, it wouldn't matter anymore. You know that. So I'm going to go with a bond priced at 1 today, no interest rates. The key is in the stock. We have three possible outcomes and only one security. Sorry, and only two securities. So this option cannot be priced. We agree with that. And the reason it cannot be priced is we don't have enough information. And there's two ways to resolve the incompleteness situation. Two ways. The first would be to introduce one or more intermediate trading periods. Let's say that I say, well, you know what, between today and tomorrow, I'm going to assume that the stock at 5 p.m. is going to have a certain value. And then it will go on to the value tomorrow, right? That's a possibility. And then I gave these two intermediate values. By the way, the bond is going to have exactly the same value. The thing with the bond prices is that I know what they are going to be. Bonds are not random. Bonds are deterministic. And with what you have done in assignment number one, we know that we can price anything, which is bond related. Yes? Okay. So I'll just introduce a concept. This is going to be the next steep hill we need to climb. So I'll introduce the concept and then we'll take a break. And then I'll tell you how this thing is going to be made a reality. But the concept is very simple. Once I introduce intermediate trading times, what we do is look at the branch that we have in yellow there. That branch in yellow is exactly the same 33-cent game we played earlier, right? So we could use that to price the option tomorrow. Not today, but tomorrow. Or at 5 p.m., sorry, right? See? And then you go to the next node, down there, next branch, you can do the same. So you can price the option at 5 p.m. tomorrow. It's exactly the same with, you see that? It's the 33-cent game. And I'm pricing the option tomorrow. Tomorrow. But once I have that, I know the option value, sorry, tomorrow at 5 p.m. I know the option price at 5 p.m. Okay, so I can price it now. This is called backward propagation. It's not a backward propagation where you calibrate a neural network. That came later. Okay, this is a different type of backward propagation, but same idea, right? So maybe what I do is I do an iterative method where the 33-cent game is now used recursively, starting at maturity all the way to today. And then I have everything. And then I have the price, the replicating portfolios, everything. Yes? Well, that works. That works. So our 33-cent game has a life where it replicates itself. And that's what I will tell you after the break. Let's take a 10-minute break, okay? We were dealing with the concept of incomplete markets and how to resolve incompleteness. There's really two ways to resolve incompleteness. I just told you the first one, which is going to give rise to multi-period finance. And by the way, this is a bit of a preview. If in that diagram I showed you here, you take, we went from 2 trading dates, today and tomorrow, to 3, today, 5 p.m. and tomorrow, right? You can go to infinitely many of them. That's going to be a lot of fun. We'll do that in 3 weeks, 2 weeks or so. Okay, a lot of fun. And that is how continuous time finance is done. And there's a lot of things that will be developing there that'll be very entertaining. That's one way to do that. But there's going to be more ways to do that. Okay, and I want you to be aware of that. And there will be lots of things to say in that situation. Now, continuous time finance is a big deal, and I'll have to spend probably a day just talking about probability analysis, many mathematical objects that I need to make sure you know. Some of you do, so we can do that. Okay, but that will come later. The only multi-period finance we will do for about a week is still discrete, still say daily, no considerations for passage to the continuum. Okay. Now the second way to resolve incompleteness is to basically wait for a new instrument to be offered by the market, and then be able to price or to complete our market. For example, imagine that we're in the situation where the stock goes to 2, 1, or 50 cents. There's nothing we can do. But then someone offers the option we're looking to buy, whose price we don't know. Someone offers that for 33 cents. At that point, the market is complete, and we can price everything else that exists out there. This is the capital asset pricing model, CAPM. So there's two ways to resolve incompleteness. We're going to see both. And the first one is called dynamic asset pricing theory, and the other one is going to be called capital asset pricing model. There's no way you can confuse them. They're completely different. In one of them, we'll start trading more and more frequently. In the other one, we will expand the number of financial instruments we're dealing with. Okay? There's two ways to resolve that. This is the dynamic asset pricing theory. It's the one that we will be spending a bit more time on today. The capital asset pricing model is where we will spend a bit more time next week. But we're going to see both. Dynamic asset pricing theory can be extended to continuous time trading. The capital asset pricing model can be extended to infinitely many instruments. And I may say a few things about that next week. The Black-Scholes theory is a particular case of the dynamic IC pricing theory, where we will be pricing options, assuming we can trade stocks and bonds continuously. And expanding the universe of securities the capital asset pricing model, is one that will lead us to understand something very important, which is how I started today, which is that prices are reflections of each other. Markets have an internal consistency where the price of something dictates the price of something else. And there's a mathematical object that we will build there. It's called the state price deflator. And that will make this theory a mathematical theory that will help us understand no arbitrage pricing in a mathematical way. But we will see this separately. Dynamic asset pricing theory, which is where I want to spend my time in the next little while, next hour or so, has really two versions of it. One is the Markovian version, and the other one is the non-Markovian version. I don't know if you know Markovian mathematics or not. Markov chains, yes, okay, good. So this has a lot to do with that. And the Markovian is the method that I am going to follow in this class. I'm not going to do anything non-Markovian. I'll tell you what it is, but that's it. Markovian is, for example, this. You probably have seen Markov processes. If you have seen Markov processes, please excuse the oversimplification of what I'm about to say, but you will understand. A Markovian process in this case is one where if the stock is $1 today and is $1 after 2 periods, whether I go up and down or down and up, it doesn't matter. It's a process that essentially has no memory. Here has a non-Markovian model where at every time you have an evolution, okay? And you can see going up and down and up does not lead to the same place. That's non-Markovian. We're not going to do non-Markovian in this course. If you want to do non-Markovian, good luck. As you can see, computationally, it becomes very challenging, right? How many, just think of the data storage needed if you're going to do a non-Markovian model, binary trees for a year. You're laughing. Do you know the answer? What's the answer? Yeah, what's the answer? Yeah, it's a big number, right? You need terabytes of information just to store that. But if you do the Markovian one, what's the data consumption? It's about 1,000, very small, 10,000, right? A few kilobytes, nothing, huge, right? So we're gonna do Markovian. These trees are called recombining trees, and they lead to memory loss. That's why they are so efficiently computational, because you forget. And these are called non-recombining trees, and they keep full memory, and therefore computationally very expensive. We're not going to do non-Markovian in this course, but I want you to know that it exists. And there are models which are non-Markovian, and some people sometimes have to use them. If you have to use them, my condolences to you, but then you have to use them. Okay, in this course, we're going to avoid them. All right, so let me now then move to episode 6, in which I'll tell you how dynamic asset pricing theory works. Okay, and I'll see how much of that I do. And I'm going to explain that with this very simple example. I'm only going to introduce an internal trading day, an intermediate one. I'm going to talk about today, tomorrow, and day after. That's all. I want to deal with a stock that goes from $1 today to $1.50 tomorrow, or down to 75 cents tomorrow. And then onward from there can go to $2, $1, or 50 cents. And up, down, up, same thing. Okay? That is one way to resolve the incompleteness. Is the one which is interesting to me, because not only will resolve the incompleteness of the market, it will actually lead to continuous time trading when we deal with that in about a week or two. And by the way, my bond is there. Dollar every time. 0 interest rates. And by the way, the reason I chose 0 interest rates is to make the calculations here easy, not because they change anything fundamentally. We've learned the discipline of dealing with bond prices as a substitute of interest rates, and then everything will be the same. Good. So, as announced earlier, I want to start with that yellow branch combination. So, to understand what's happening today, I think of tomorrow first. And the situation I have here, I have a stock that is worth $1.50. I can go to $2 or to $1, and a bond which is always 1. We can price any option that way, right? Because for that branch, the market is complete. I have 2 stocks, 2 scenarios. Sorry, I have 2 instruments, 2 scenarios. The system of equations it leads to is 2 by 2, as we saw earlier, so we can always solve it. We can do anything. We can solve that. When I go to this one, I have a stock which is worth 75 cents and go up to $1 down to 50 cents, and a bond that stays the same. As usual, as before, I can solve for this. I can solve for anything. And this one is interesting because I have a stock that is $1 today and $1.50 or 75 cents tomorrow, a bond that does nothing. I know that. But then what about my option? You could say that my option at that point is not going to give me anything, right? Because you have to wait until the day after tomorrow to be paid, right? Okay, no. One of the consequences of the arbitrage-free pricing model is that I don't care if the option gives me $1 tomorrow or if the option is worth $1 tomorrow. It's the same thing to me. And that's a consequence of the arbitrage-free pricing theory. My house is worth $1 million. I don't care if I have $1 million or a house. Obviously, that's not true. I cannot sleep on $1 million. I cannot cook on $1 million. I need a home for that. But we're not looking at that perspective on things. As a consequence of the arbitrage-free pricing theory type of thinking is that I could sleep in $1 million. Sure, because $1 million is the same as a home. And we ignore the process of buying a home. You can do it for free, buy and sell the home 1 million times in a day, okay? It's a very extreme simplification, but an important one for us, because once we adopted the value of the option tomorrow that we calculated when we did the yellow branch, we don't distinguish whether that's cash or in-kind, an option. We don't care. So the arbitrage-free pricing theory has also that additional benefit to us, which is asset values, cash, payments, is the same. That's where we can do things. You understand this? Okay, great. So let's say that I have an option that is now going to, it's not going to be exactly as so the cash flows are the same, but I'm going to say it's an option that will pay me the stock price minus 75 cents, only when the stock price is above 75 cents. Okay? Well, obviously, what are the payoffs of the option? It's going to be when the stock is at $2, it's $1.25. When the stock is at at 1, it'll be 25, and when it's at 0, it'll be. Sorry, and when the stock is at 50 cents, it'll be 0. You should know that that sub plus symbol here, that sub plus symbol here, this denotes what's inside if it's positive, and negative what's inside when it's negative. Okay? It's like the absolute value, except it's positive on the positive side and 0 on the negative side. Okay? I don't know if you've seen that before. We're going to see that very, very often going forward, because this is going to be very useful for us to explain options. And at this point, I need to pause. I know that I could very quickly now go through this example and price it for you and this and that, and you can, there's going to be 3 systems of equations and it's all great. But I'll be doing, if I did that, I'll do something that I don't believe in, which is I will be doing math for the sake of math. I just made up this problem for you, right? And before I move on, I want to spend as many minutes as needed for you to understand how important this is. I need to do some finance. I've done too much math today, up until now. Okay? Yes? So I need to pause. Many of you already see what's coming. In fact, if I left you alone, I'm sure you could do it on your own. But there's one thing that I need you to know before you can solve this math challenge. And for that reason, I want to play another game, someone else. Let's pretend I am the chair of the board of a big company, say IBM. Okay? And I'm looking for a CEO. I need to hire a CEO for IBM. Any one of you wants to be the CEO of IBM? Okay, I'll give you some advice, okay? If you want to succeed and someone offers you a job, you raise your hand immediately, okay? Like, don't delay 5 seconds, okay? You're not gonna be hired. You understand what I'm saying? So who wants to be the CEO of IBM? Okay, so you, what's your name?
Shane.
Shane?
Yeah.
Shane, okay, great. So Shane, you're a candidate to be CEO of IBM. Yes? Great. So I go and I say, okay, that's fantastic. You have all the qualifications. Oh, wow, you took APM466. You must be really smart. All right, wonderful. Good for you. So we negotiate everything. Now we come to the salary part. Yes?
Yeah.
How much do you want to get paid?
Like 2 million.
2 million what? Yuan?
Cash?
Yen?
No. Yeah, Canadian dollars.
Canadian dollar. Okay, fine. 2 million Canadian dollars. Yes, that's it.
Like for bonus, I can get options.
Options.
Yes.
What do you mean options?
Like if I successful like rise the stock price for the IBM, then I receive a bonus. Like for the option, I mean like I could only claim the option if the stock price rises to.
Very good. Thank you very much. That's a very good answer. Okay. But now let me say it. By the way, if you get called to be the CEO of IBM, call me first to go to the job. Before you go to the job interview, okay? You don't say those things. I'll teach you how to say it. Okay. So let me answer for you. But your answer is correct in theory. But okay. So thank you for that. That's a good answer. Let me ask you one thing. What is the job of a CEO? Go to business lunches, go to business trips.
Maximize value for shareholders.
Exactly. It's maximize shareholder value. That's their job. And that's the stated job. At some point, actually, in the last class of this course, I'll introduce some considerations there, which is, let's say that's the result. It's very different to, it's important to understand the difference between objectives and results, okay? So let's say that the result of we agree with that. The result of whatever the CEO does should be maximize shareholder value, okay? That's what CEOs are hired to do, maximize shareholder value. So how do you pay a CEO? You just pay cash.
And also you want to pay down the stocks. So the stock.
Well, see, that's the thing. What is the right compensation? You should understand that people do what you pay them to do, right? You take a CEO and you pay a CEO $2 million, they will say, oh, $2 million, that's great. What do I have to do for this? Well, go to work. Okay, great. You go to work, right? You're paying them to go to work. And they will work. They go to work, they will be there, they will look very busy, and they'll take a lot of phone calls and this and that. If you want them to maximize shareholder value, the thing to do, what people realize is that, well, then we have to give them a percentage of the shareholder value they create, right? So let's say that your IBM stock is at 75 cents when you're hired, right? So, well, a way for me to, I'll pay you some cash too because you have to eat. But the best compensation I can give you as the CEO of IBM is to say, well, you know what? I'll pay you for every bit of worth you give IBM stock, right? And that's exactly what that expression there says. You could say, oh, but if the stock goes down, he should pay me. No? Well, you can't do that. It'll be very hard to find CEOs for anything that will pay you if the stock goes down. You can't do that. And I'm not even sure that it's against the, it's probably against the employment laws that employees pay you, right? So this is how executive compensation packages work. You pay your executives a portion, meaning you give them some shares, obviously. If IBM has 1 billion shares out there, I'm not going to give you just one of these. I'll give you how many? Well, we negotiate 1,000 is enough, 1 million, how many you want? But that is going to look very much like this. Understand? Okay, so for a long time, these types of options were used to compensate executives. In fact, going back to the game Harsh and I played, that was a game, right? I never told you who cares in the world of finance about that game. Well, it's the same reason, right? It's exactly the same reason. In that case, it would have been more difficult to make the point. Here is more clear. This is the beauty of introducing three possible outcomes for the stock as opposed to only two, right? But you could think the same. Maybe that was JP Morgan, and I hired the CEO of JP Morgan. And if the stock goes to 2, oh, I'll give you 1. Oh yeah, I'll be very happy to give you 1 if the stock goes to 2, right? Yeah, I'll give you a few of those shares. It's the same thing. You could think of this as a way to compensate executives. But there's other ways to think of these options. We discussed last week, I told you how in Canada, when the Canadian dollar goes up, companies suffer because their payroll is in Canadian dollars and their income is in US dollars. Maybe after today that's going to change. We don't know. But normal Canadian companies have their income in US dollars and they pay in Canadian dollars. So if the Canadian dollar drops in value, they're happy. If it rises in value, they're unhappy because they have an imbalance. What do? They go to a bank and they buy insurance for that. Very similar to the game we played this morning also, right? If the Canadian, you can think of instead of an asset, you think Canadian dollar. If it goes to $2, damn, you have to give me something, because, right? If it drops, no, I'm very happy. So you pay for the protection against the Canadian dollar going up. That's another way to think about that. And this could be the same thing. Instead of the IBM stock, I could say the Canadian dollar is at 75 cents US. And if it goes up, you pay me. Actually, here is the 75 is 75, slightly different. But you understand what I'm saying. It's reversed. I want to get paid if the Canadian dollar goes up because that's when I lose money. And this assumes that I am pricing my Canadian dollar at 75 cents US. If it goes up, I get paid. And if it drops, oh no, then you don't have to pay me. I'm happy. I make money because my payroll is cheaper. That's another example in which these things could come up. And there are many other, we'll see many other situations where this type of asset protection come up, and that's what options do. Now, you may know or may not know this thing called the Black-Scholes theory. You know that? Black-Scholes theory. Okay, we're going to see that in great detail. Well, no, not in great detail. No, sorry. We're going to see that very fast, as with everything. But we're going to see enough so we understand. Now, it's called the Black-Scholes theory because it was originally developed by two people, Fisher Black and Myron Scholes. Myron Scholes is actually a Canadian from Timmins, Ontario. And I would add a third name to that, which is Robert Merton. We'll see what they did. We'll see what they did later on. Merton and Scholz, they got the Nobel Prize in 1997 for what they did. Fisher Black was dead. He didn't get the Nobel Prize. But it's very interesting to read the Nobel speech of Myron Scholz, which is actually on the website, on the course website. You have it. You can read it there, where he explains how this problem was brought to him. And it was brought to him through a consulting engagement from, I think it's Wells Fargo Bank. And that was to price this, compensation, executive compensation packages. Because in 1970, people didn't know how to price this. This thing that you're listening to me tell you about, these things were not known. A few things were known, but not as you are seeing them today. All of this happened since 1970. And employees, executives were being paid packages like this. And when the board of IBM hires the CEO and says, yeah, I'll give you $1 million of these options, say, well, how much is that? I don't know. It looks like the right amount. And if this happens, I make money. If this happens, I always make money. I'm very happy. But then the accountant comes and says, well, you just issued this. How shall we value these things? I say, I don't know. Now we know. And not only we know, we in fact know how to replicate them and this and that, right? So this is all the things that financial markets have matured since then. So when I create these situations here, maybe they're mathematically interesting and we do all these things and we have all these equations, it's great. But I want you to understand that finance needs this. These things are used in finance every day. Whether it's to protect against the Canadian dollar going up, whether it's to pay the next CEO of IBM, or who knows, all right? And this symbol that you have there with the bracket and the plus is called a call option, which is, for example, in the case of CEOs, that's what you would pay them. Say, oh, you're going to be hired today. The value of the stock is 75 cents today. So from here on, we'll pay you for the stock going up. If it goes down, well, we don't pay you. And that's why that symbol is there. Understand? So we're going to use that symbol a lot. And you should know it reflects this situation, which has been very, very common for decades. Originally, to pay executives, but in everyday finance, most insurance contracts in the form of options are stated like that. Okay, so now I can continue. Now you see that this thing I'm talking about is a live animal. It's not something which is there just to come up with new equations. Okay? All right. It's important for me that you know what I'm talking about. Very important. It's important for you that you know what I'm talking about. Okay. So in this particular situation where I have this option, and now I understand I need to price it, what I do is I look at the yellow branch. The yellow branch is a situation where I have a stock, which is $1.50, and it can go to $2 or $1. And an option, I don't know the value tomorrow. I don't know the value tomorrow. I know the value the day after tomorrow, which is it'll give me $1.25 or 25 cents. So how do you solve that? Oh my God. How many methods do we have to solve this now? You can do replicating portfolios. Yes. You can find the replicating portfolio. You can calculate the risk neutral measure, which is find the probability that prices the stock correctly, right? Or maybe you can go with something else. In this particular example, I'm going to choose the replicating portfolio. You will see why. So I find the replicating portfolio, which is I buy the stock and I borrow 75 cents. And that gives me the right payoff. And in particular, it tells me that the option tomorrow will be worth 75 cents. I'm not going to walk you through these calculations. You know how to add, subtract, and divide and multiply. Yes? Okay, so, and I don't think I made a mistake. I've used this example many times. But if someone finds a mistake, let me know. I think the numbers are correct. You will all know how to do this. Am I right? We climbed that hill together 2 hills ago. Yes? System of equations, blah, blah, blah. Yeah? Okay, you could write Python program for that. You could do that too. Great, okay. So I have my yellow branch done. I'm gonna go to my green branch now. Green branch, I have an option. I don't know what it's worth, but I know it's gonna give me 25 cents if the stock goes from 75 to $1, and it'll give me nothing if it drops to 50 cents. And I can, again, pick your favorite method. System of equations, risk neutral measures, replicating portfolios. I'll pick replicating portfolios. That's the replicating portfolio. I'm going to buy half of the stock, and I'm going to borrow 25 cents. And the value is 12 cents and a half. You're bored by that. Did you know how to do this? Yes? Am I right? Everybody knows what I'm talking about? No one has been lost, right? You're lost?
Yeah.
Oh my goodness. No, tell me, where are you lost?
Where did you get the half a stock and what's the cost?
Okay, so there's a system of equations. Remember there was a system of equations? So that has another system of equations here. I didn't write it down because then there will be lots of junk in my slide. But
Oh, okay, so you just use that stuff?
that, exactly, yeah. So I did that in a separate piece of paper. I said, oh, this is the answer. I made a mistake, I fixed it. Oh, I made a mistake, I fixed it again. And then I wrote it here. Right? I didn't do anything that we haven't already learned. I make a lot of mistakes when I make these calculations. I'm a follower of Paul Erdos, who says, never multiply in public. I'm one of those. Okay? And in private, I make a lot of mistakes, but then I fix them. And I think these numbers are right. That's how I do it. You're good. Yes? Everybody's good? System of equations, 2 by 2. Very simple. Great. So I can do my green branch. And then I go to my red branch. And in my red branch, this is the one that requires some different thinking because I have an option. I don't know how much it is, but I have to pay something. But I have a stock that goes from $1 to $1.50 or down to 75 cents. If it rises to $1.50, well, you can say I'm not being paid anything. I say, well, yes, no, I am paid something. I am going to be paid 75 cents. Because I don't distinguish between being paid 75 cents and having an option that's worth 75 cents. I don't distinguish because of the absence of arbitrage, right? Oh, if it's the same, it's not that I'm going to get paid. That's operations. But I have something that's worth 75 cents if it goes up. If it goes down, I have something that's worth 12 and a half cents. Right? So there's another system of equations. Right, Rahul? Yes? And then that will have a replicating portfolio, which is that one. I buy 83 and a third of the stock, 83% and a third of the stock. I borrow 50 cents, and the option is worth a third. Done. So I know that every option I give you as CEO of IBM cost me 33 cents. That's the accounting value. Wow. Yes? Okay, let me tell you another story. Again, I need you to understand all of this, not just mathematically, just systems of equations, but this has tremendous impact. There was a case shortly after this was introduced in the 80s. You know a company called Procter & Gamble? Yes? What do? They sell stuff, right? Like they have a number, like for example, Tide detergent is theirs, and lots of other things. All right, so it's a very big multinational, and in the 80s were periods where there was a lot of uncertainty in financial markets, especially in interest rates. It must have been very interesting to do your assignment number 1 in the 80s. Every day. So this company entered into a certain transaction with a bank. It was Bankers Trust. You don't know who they are. They were bought by Citibank a long time ago. They entered into a transaction that was basically something like this. Okay, if rates go up, okay. So it was a transaction that went bad because Bankers Trust was very smart, and they ended up this thing where I told you you charge 50 cents for something that's worth 33. Remember? It was worse. It was worse. It was a swap that was so built that no matter what happened, Procter & Gamble will have to pay. That was the early days. It was easy to rip off customers with options. In fact, there was a lawsuit, and the investigators came out with some tapes, recorded tapes of people, employees of Bankers Trust. Banks have to record everything by law, right? So they went through that, and there was a term was called the rip-off fee. No, the rip-off spread, a rip-off something. Okay. Remember how I told you that everybody works for free here? Well, in those situations, no, not only you don't work for free, but there was something that employees talked to each other about the rip-off factor or something. Okay, and that was a big scandal. And it was settled out of court, and Procter & Gamble was, received some settlement. But there was one shareholder of Procter & Gamble that was very upset about this, and he actually sued Bankers Trust personally. And the lawsuit against Bankers Trust was not about the swap. Think of the swap as this. He was saying, this thing you have here is gambling. And gambling is illegal in the state of New York. In other words, what he did is he went back and said, what I played with Harsh is the same thing as I played with Rahul. What I played with you is illegal. It's gambling. It's okay in Nevada, but not in New York. Gambling is not legal in New York State. Do you think this was a joke? All the lawyers of all the banks started to ruffle through papers. Oh my God, this what happens now? Because there were derivative transactions in the billions, right? And if they're all illegal, imagine what it. And there was a hearing. And derivative trading was not declared to be gambling, because then we would not be having any derivative trading. It's illegal. You know what happened? Can you guess how this ended? Yes, you can. Someone an expert witness stood up and said, gambling. No. Let me explain the Harsh example and let me compare with yours. There's replicating portfolios. Oh, the judge goes, oh, they're replicating portfolios, but there is no gambling. Then, no case. You understand? If it was gambling, maybe it would have been declared to be illegal, and maybe there would be no derivative trading, but it is not. So this thing that you're seeing here also has an impact in why derivative markets even exist. Understand that? Okay, this is very interesting. And I need you to understand the full context of that. It's not just about the systems of equations. No. It's much. In fact, the systems of equations is what allowed these things to not be classified as gambling, which would have made them illegal instantaneously. Okay? Okay. So another example from here is this. Look at how interesting this is. Imagine I am now the bank, and Harsh, say, buys this from me. So I'm trading this with you, all right? I said, I know I have to give you $1.25 or 25 cents or nothing. So I'm gonna go to work and I'm gonna set up my replicating portfolio today. So I borrow 50 cents and I buy 83% of the stock. You see that, right? Which I can do with your 33 cents. You see that? Great, perfect. Now, tomorrow, let's say the stock goes up. What What happens if the stock goes up? What do I need to do? Tell me.
You need to rebalance your portfolio.
Exactly, which means what? Tell me exactly what I need to do.
Buy stock.
I need to buy more stock.
And borrow 75 cents.
And I have to borrow some more so I can buy more stock, right? And what I need to borrow is exactly what I need to buy the stock, right? You can check. Someone could be thinking, wait. The stock goes up and now you're buying? You may have been taught that you buy low and sell high, right? It looks here that I buy high and I sell low. Because look what happens if the stock goes down. If the stock goes down from $1 to 75 cents, what do? I sell 23% of the stock. You see? So I'm buying high and I'm selling low. Something wrong here? Something wrong here? They taught you not to do this, right? Now I'm teaching you to do the opposite. I'm telling you to buy high and sell low. What's wrong?
Like you basically have a negative portfolio because you are giving an option.
The thing is, this is not investing. This is hedging, right? So what you think is the following. You think is the following. Look at that. This is the IBM stock I'm paying you, right? If it goes up, forget, $1 to it goes to 100, like to 100. This option is, I have to give you 100, almost, right? Right? It's linear with a slope of 1 with the stock. So someone could have thought, someone who doesn't know this, said, oh, if I have to hedge this, I have to buy the stocks I have to give you, right? The price, 75 cents, is not a big deal. So in fact, today, I should have bought not 83% of the stock, I should have bought the full stock, right? I said, no. 83% is enough. That's the savings you have. It's enough, because if it goes up, you will buy more later, but not now. Because if it goes down, you have too much. You have to sell some. Understand? This is hedge thinking. This is risk management thinking. And thinking risk is very difficult. We'll spend a lot of time on that, I don't know, in a month or so. But on our way to risk thinking, think that we're actually buying high and selling low. And it's the right thing to do. Because the way we make money is not by trading, right? We'll have to charge harsher fee. That's how we make money. This is hedging. Okay, this will come up again and again and again. Okay, just these are the things that you have to pay attention to. Time for a break? There's a question that many people had, and I guess it's more than a question. I think it's probably a doubt or something which is wrong. So let me address that here. That replicating portfolio, I use my iPad. The replicating portfolio here. Okay, that's yellow branch, right? Let me give you the easy way to understand this. The easy way to understand this is by hindsight. I'll tell you what the replicating portfolio is. Check that this gives you the right cash flows. So when the stock goes up to $2, 2 minus 75 cents is $1.25. If it goes down, it's $1. So 1 minus 75 is 25. Works. Okay? That's it. You say, oh, I understand that. But how did you know? Well, no, I did not know. I solved the system of equations. So I solved the system of equations to arrive at the replicating portfolio. I don't have the system of equations here. I don't think I need to tell you what they are. You do them yourself, right? And then you will get the same replicating portfolio as me. I know you will because we just checked that it works. There can only be one. Yes? Now, once I have the replicating portfolio, well, what's the price of the option? It should be the same as the replicating portfolio. How much is the replicating portfolio? Stock is $1.50. The bond is 1. So the option is 75 cents. Right? So the only issue is how you come up with this replicating portfolio. But it's by solving the same linear system we solved earlier, like 100 slides ago. And even that system of equations is not something magical or mythical. It's the system of equations that looks for that number and that number so that it matches the cash flows. You just set it up. This is the easiest linear algebra problem you have ever done. Guaranteed. Wrapped into a lot of mystique with the CEO of IBM and who knows what, but that's what it is. It's a very simple system of equations. I believe we've learned a lot for a day, but I'm ambitious. I think we can learn some more. I really think we can claim one more hill. Because then everything is the landscape once we climb this last hill is gonna be awesome. Fantastic. And that's the CAPM hill. So I'm gonna tell you about capital asset pricing theory. And for that, we're gonna go back. We're not gonna do anything new. By the way, as you realize, we've only done one thing today, the 33-cent game. Replicating portfolio, solving. That's all we have done. Everything else has just been built on that. So I'm going to do exactly the same thing, but now I'm going to become a little bit more mathematical on that, and I'm going to ask you to think the following way. I'm going to think of an event space where things could happen or represented by a set, just the way you do formal probability theory. And each thing that could happen is an event. An example, in our first episode, the event space was stock goes up, stock goes down. In our second example, there was stock goes down, stays flat, goes down. 3.
So I was going to ask, like, why we have the finite events, right?
Because I want to show you the simplest possible model. Once we get deeper into this, I will show you what you need to do to deal with an infinite event space. But that requires that you know what L2 is and this and that, and I'll come to that. I do it so that the translation is easy and so that I don't lose anybody. We'll have to climb this hill together. That's why, okay? If I talked about infinite probability spaces, I am not sure that we'll be able to climb this hill together. Not disrespect for your knowledge of probability theory, just a lot of practice. Okay? I need to make sure that absolutely everybody can walk with me. This is something that everybody can do if you've taken basic accounting. Okay? All right. Imagine you had 2 stocks. Then what's my event space? It's going to contain 4 elements. Both go up, both go down, up, down, up, right? So that's what we're going to model. And note that we're modeling this in the single step process framework. We could do this for the dynamic acid pricing theory, in which I will have to replace sigma algebras by filtrations. And if you know what that is, good for you. But it's not something that I'm going to be explaining here. So if you want to, when CAPM is mixed with dynamic acid pricing theory, it gets to be very interesting, very sophisticated. It's not something that I want to emphasize in this course. But if anybody's interested, there's a great book that explains all of that to you. You have more Hilbert spaces than you've ever seen. It's all great. But not here. So that's the way we're going to be dealing with event space. And now, basic probability theory. This is the event space. On that, we have a sigma algebra. Remember this thing? You've seen sigma algebras? This thing that is sigma algebra is something that allows you to do everything that probability requires you to do. Like look at the complementary, taking unions, and all of that stuff. You've seen that. I have no interest in pursuing any of that in this course. Now, the payoff space is the following. If omega represents the source of randomness, what I need to know is the instruments which are in the market, how do they behave under that randomness? Okay? So the payoff is going to be a random variable that each of my instrument has that lives on that probability space. So if you've seen probability theory the formal way, this would be a random variable on that probability space. For us, is a matrix that will tell us for each of my instruments, which I believe represents columns, I would have what is their value under every possible event, which I think are rows. So for me, that's a matrix. You can put this into Excel. But really, this is a random vector on my probability space. And you can think of it either way. Spreadsheet way, random vector on a sigma algebra way, up to you, I don't care. Yes? I want to give you an example. Very often, security is considered to be the bond. The bond is special. Why? Because we know everything about it. There's no uncertainty in it. And this is all about payoff under uncertainty. The bond is always the same. You say, I don't care. Stocks go up, I always give you the same. You may think, hey, wait a minute, I heard that if stocks go up, bonds can do something else. That's different. That's the evolution of the yield curve, as you have seen in your assignment number 1. But that's not what I'm talking about. A bond is guaranteed cash flows. This coupon payment every 6 months, and therefore known outcome. That's the type of bond I'm talking about. I'm not saying that bonds go up. The price of a bond could go up and down as the yield curve goes up and down, as you have observed in your assignment number 1, but that is not what I'm talking about here, okay? This is just the evolution of, say, a savings account or a risk-free evolution of money. And this matrix that we have is called a payoff matrix. And I believe I like to do instruments in columns, events in rows. Other people may do the transpose. Fine. I like to stay consistent with myself, and that's why I like to do instruments by rows. And then we also have the cost of all these securities, because all of these securities, who knows what they will do tomorrow. They are in a tree or something, but today I know the price. And the price of the bond dictates interest rates. So this contains a lot of market information. That's the framework. It's nothing new. I'm just encapsulated all the information we've been using today into this formal language. I'm not doing anything new. That should be clear to everybody, okay? I'm introducing language so we can start to attempt more difficult things. Okay. So our setup then assumes that I have instruments whose prices today I know and whose payoffs in the future I know, under all the possible things that might happen. This is my generalization of the 33-cent game. We assume that all of these numbers are finite, but as you will see when I prove to you the fundamental theorem of asset pricing, you will see that if the number of events is infinity or the number of securities is infinity, if you know enough math, if you know functional analysis, you will see that all of this falls very nicely into the Banach and Hilbert space theories that some of you may know. But if you don't, I don't care. We'll do it with linear algebra. We'll do it it's going to be just as good for us. And in any case, you may end up having to program this in Python, in which case you'll probably program it this way and not using any Hilbert space theory methods. Not for this. For other things, yes. Like if you want to understand the dynamics of the yield curve, there you use the spectral theory, which is a Hilbert space construction, and you do it that way, but not for this. So we're dealing with a matrix and a vector. And now, the financial instruments that are given to us, their payoffs, this matrix, have a span of payoffs. That span could contain all of the Euclidean space or not. That's where complete or incomplete markets arise. Complete markets will be where the payoff matrix generates all of the Euclidean space, and incomplete markets are where it doesn't. Which is exactly the same situation that you addressed when you did linear systems of equations. Right? Exactly the same, except here we have a notation which is, that's incomplete, that's complete. Whereas when you did Gaussian elimination, and this, I don't know what terminology you used, but it was not market related. That's the only difference, which is exactly the same. Okay? Everything in the payoff can be priced. Everything not in the payoff cannot be priced, but that's normal. That's clear now, because everything in the span of the payoff is a linear combination of the payoff. So if it's a linear combination, of course I can price it. I just need to find what it's a linear combination of, and that's it. But if it is not a linear combination of anything, then I cannot price. We're not doing anything difficult. We're doing linear algebra. Okay? So in our first example, 33-cent gain, the payoff matrix is this one. Columns are instruments. The first one is the bond. Events are rows. First row, stock goes up. Second row, stock goes down. If the stock goes down, my bond is 1. If the stock goes up, my bond is 1. If the stock goes down, my bond is 1. 1, 1. First column. Second column, the stock goes up is 2. Because that's the second instrument, the stock. The stock goes down, the stock is 50 cents. Went down. That's my matrix, right? By the way, if you look at the equation that we used to solve the replicating portfolio, this is the matrix of that system of equations. So by now you should be like bored to death. It's like, why are we still here, right? You see, it's the same over and over and over and over again. It's like Groundhog Day. Every episode is the same as the previous one, except some nuances, but it's really the same. My cost vector was 1, 1 if interest rates were 0. And because the span of that is all of R2, that was a complete market. We could price everything. And there always exists a replicating portfolio. Right? Are you bored by now? You should be. Just I've been talking for 10 minutes. Trivialities, things that you already know. Example 2. That's my payoff matrix. Bond, 1, 1, 1. Second instrument, stock, 2, 1, a half. That encapsulates the market situation. My cost vector is B1. I allow interest rates to be not 0, possibly. But now I know that's an incomplete market because I don't have enough information. That particular payoff I have there is not in the span of my payoff matrix. Right? I could only price things that were in the span of the payoff matrix. That one is not.
So could you repeat the last slide?
That payoff is not in the span of the vectors in my payoff matrix. It's not. If it was, If I had given you an example of a payoff that happens to be, I'm making this up now, 1, 0, and minus a half or something, there's, oh, I can price that. And then I would have fooled you by making you think that maybe you can price everything. No, that you can price. Everything in the span you can price. But if it's not in the span, you cannot price. So it's an incomplete market. Okay. I know I need to stop. This, I have lost some people. I can even point to who I've lost, I think. That's dangerous. I don't want to lose anybody. Not today. Maybe not tomorrow either, but certainly not today. Because then everything will become very difficult next week, okay? It's more difficult for you to catch up on your own on this one. Yes?
So the instrument that's represented by the vector 1, 0, 0, like what is that?
The instrument, that's the option.
Oh,
Right? If the stock goes up, gives me 1. If it stays flat, gives me 0. If it goes down, gives me 0. Right? Instruments are columns. Good question, by the way. Good question. Because I think other people had the same doubt as you. They just didn't want to raise their hand. Are you okay? Are you sure you understand everything? Like everything? Yeah, you sure? I am sure you're not understanding everything. Ask me a question. It could be about the weather, I don't care, but ask me a question. No? No? Anybody wants to ask me a question? I'm not doing anything new. I'm using very weird language. That's all I'm doing. But we need this weird language so we can actually make progress. Yes?
Could you explain the intermediate state, like how does it make the...
Oh, no. No intermediate. No, please. No, this is CAPM. This is capital asset pricing. No, that's dynamic asset pricing theory. No. Good question. Don't mix. There is a theory, there's a capital asset pricing theory which deals with dynamic asset pricing theory. But no, sorry, no. This is too much for one day. No. In fact, we're not going to see that theory in this course. If anyone wants to see how the CAPM marries dynamic asset pricing theory, there's great books for that. Not in this course, no. Here we're doing one or the other. We're not doing which is very interesting, but there's lots of other interesting things that I want to talk about in this course, and we only have 36 hours. No. Okay? Are we good? Are you sure we're good to continue? I haven't done anything new. I'm using weird language, that's all. Okay? I don't know. I have a feeling that I'm losing some people. Yes. Thank you for asking. Thank you.
So, Prof, the first column for the P matrix is all 1 is because like today's price is 1.
No. Good question. So the 111? No. What that is the following. Let me ask you. I'm gonna ask you 3 questions, the answers of which are the components of that vector, that column vector. What's the bond worth when the stock goes all the way up to 2? The bond. 1. Okay. What's the bond worth when the stock goes all the way at 1? Only stays at 1. 1. What's the bond worth when the stock drops to 50 cents?
I guess it's 1, but I don't know why.
You don't know why? Well, a bond pays how much? What's the payoff of a bond? Always 1, right? A bond, when it's time to maturity, gives you $1. No questions asked. No one asks you what the stock did when they give you the bond price. It's always 1. The stock could go up or down. It's always 1. That's not the bond price today. What's the bond price today? What's the bond price today? That's not in this diagram. I don't know. It depends on interest rates. We call it B. B is not here. This is the payoff. The payoff is always at the end. And there's only one at the end. That's why this is not dynamic asset pricing theory. There's intermediate steps. That's his question. No, I'm not addressing that. Either one step and many situations, or dynamic 2 per jump. That's all we're doing. In this course, that's all we are doing. That's all we need to do, by the way. Okay? Yes? I'm looking at you. Yes? Okay. So that the 111 there is the value of the bond. Tomorrow, as the stock goes up, flat, or down. It's one, it's a bond. Right? The stock, no. If the stock goes up, it's 2. If it stays flat, it's 1. And if it drops, it's 50 cents. That's the second column. That's the payoff matrix. We're only dealing with the payoff matrix. And the option, that gives you 1 if it goes up, 0 if it stays flat, and 0 if it goes down. What's with this option? 1, 0, 0. It's exactly that. It just says what the option does. And by the way, 1, 0, 0 is not in the span of those two vectors. You know that from linear algebra. It's not. There's no linear combination of those two vectors that will give you 1, 0, 0. That's where you cannot price it. But if you write a vector that happens to be by a miracle in the span of those two vectors, then you can price. Because if it's in the span, it's a linear combination of those two. So if it's a linear combination of those two, there is a replicating portfolio, and therefore there is a price. Yes?
So instead of like the payout being 1, 0, and 0, if it was like 1, 0, and negative 0.5, then we could create the replicating portfolio.
Actually, you're tricking me on that. 1, 0, negative 5. That is in the span. Yeah, that's in the span, right? Because that is a one stock short one bond, right? Then yes, another price. The price is one stock short one. The price is what? Is 0, right? The price of that option is 0. It's not an option anymore, because options have to have non-negative payoffs. That's why they're called options. You have the option, but not the obligation. There you have an obligation. It's not an option. It's a derivative, and the price of that derivative happens to be 0. Okay? Yes?
Sorry, like for an option, like I could approximate that, like
Approximate?
yes.
No.
Like,
No. I allowed you to approximate doing linear interpolations because you have to do something. But here, no, that would be no. Very bad. Very non-arbitrage free. No. You're gonna no. The answer is you can't. Either you introduce a new instrument or you trade intermediately. There's no way to do anything else. Yes.
Are you only guaranteed a replicating portfolio when this span is the same dimension as the vector? Is that the idea?
When the span is the entire Euclidean space. Because then, if the span is the entire Euclidean space, then every vector has a linear combination. Then it's a tautology, because if every vector is a linear combination, and linear combinations is what I do to create replicating portfolios, and therefore prices, of course the answer is right. It's the 33-cent game, just with very weird language. Yes?
What's the implication of an option not being able to be priced?
You need a market maker for that. Someone is going to take risk. Okay? And that happens in practice. We say, oh, you know what? Oh, I'm willing to do it for whatever the reason. Okay? And this is what investing is all about. Investing is taking risk to make money. And then other considerations come into play. It's not finance, it's investing. That's what hedge funds do. And that's how they make money. And hedge funds are liquidity providers. They give you things that you wish existed, but don't. You want to hedge this mortgage book that has exposure to the evolution of interest rate markets, they will do it for you. You don't have to worry. They run the risk, and you pay them for that. And that's called investing. That's the last 2 lectures of this course. Yes?
Everything within the span of this 2D, like 3D space is not an option.
Okay, so financially, an option is something that gives you the right, but not the obligation, to buy something at some price, which in mathematical terms corresponds to something whose payoff is not negative. Okay? So, of course, many things in the span will be negative or may have components which are negative. Then those will not be options. They will be derivatives, not options. Options are characterized by the fact that you pay a premium, but then that's it. You don't have to pay anything else anymore. A forward or a future are derivatives, you may have to pay, right? You have guaranteed delivery at a price and you may have to pay, but there's no upfront fee. Options have upfront fee, but the result is that that's it. You don't have to pay anymore. On a swap, you can pay now or you can pay later too. They are derivatives. We'll see all of that maybe next week. That's financial terminology. Yes.
So we talk about the bond price, the payoff from the bond is one. No,
The payoff of the bond. So the bond always give you $1. Doesn't matter what the stock does.
But you also need to pay for the bond.
I'm not talking about that. That's the cost of the bond. We called it Q. Remember? That's the cost of the bond. This is the payoff. This is what will happen at the end. What you pay for the bond now is the cost of the bond. What you pay for the stock now is 1. What you pay for the option now is X. What you pay for the bond now is B. I don't know, depends on the interest rates. That's the cost. Today is the cost. Tomorrow is the payoff.
Okay, we're not talking about net payoff.
What?
Like net payoff.
Net, I don't know what a net payoff is. I know what you're talking about. We'll call it return, but no, we're not talking about that. No. The relationship between the price today and the price tomorrow, what was the yield for the bond? We're not talking about that. We're not talking about that. No. Different things. Dollars today, dollars tomorrow are very different because dollars today we know. Dollars tomorrow we don't. They are random things. For pricing uncertainty today, we were not doing that last week. Maybe that's what's confusing you. You were looking for, you're thinking more than pay or think of profit, right? No, we're not talking about that. That's why bond is always 1. When the bond matures tomorrow, give you 1. Whether the stock went up or down, I don't care.
Oh, so why are we assuming the price to be like discrete?
Why?
Yes.
Because I want to make sure everybody understands. There's no mathematical reason. This could be continuous, but then that's a different course.
Like, the discrete way you are describing, is that with how we deal with the option pricing? Is that
In this course, I only do discrete because I want everybody to understand. No one is allowed to walk away from this course not understanding this. Everybody has to understand. And I know I can do it if everything is discrete.
Can I ask a quick, like how well does this approximate the
Allow me to answer that question either next week or the week after, okay? I will tell you, you will love it, okay? You will love it, but not everybody else. I think this was enough for a day. I have a very good feeling. I was planning to do more, but I think I'm okay. I can stop here. I don't know how many more slides I was planning to do, but that's okay. I'll take it from here next week. Remember where we were, okay? We will do, it's important. Reflect on this. Please make sure that everything we did today is understood next week, and then next week will be a walk, okay? Bye.